All right, so today we're going to talk about expected value. We're still working with probability distribution. You're still going to have your random variable, and we're still doing discrete random variables, okay? All right, so we are going to compute the expected value of a random variable, and then we're going to draw some real-world conclusions from that expected value. So when dealing with discrete random variables such as this one is where the number of pets in a household, I want to know how many would you expect a selected person to have. So just by looking at this chart, what do you expect a random person to have? So when you're looking at probability, the higher probability you have, the better chance of it happening, right? So if you looked at this probability, I would see that having 2 pets is a 40% chance. So my educated guess, I would think the random person would have 2 pets because there's a 40% chance of it. That would be my logical expected value. Well, there's actually a way you can find the expected value. So there's this really awesome formula you have here so that you get an exact, accurate answer. So that was just a guesstimate answer, okay? To get an exact, accurate answer, even though we can't realistically have a decimal number of pets, we find the mean or the expected value, okay? So we know we can't have a decimal amount of pets, but this formula will probably give us a decimal, okay? All right, so it's represented by the Greek letter mu, okay? And that's right here. So that's the expected value symbol. Now this means summation. Anytime you see the big E, that means summation. Summation means to add. So I want to add all the what's the word I'm looking for? All the products of x times p of x. Now we've already gone over what x and p of x is. X is your random variable, right? P of x is the probability of that random variable. So I want to add up all the products of the random variable times the probability. That's really all you're doing. Okay? So in other words, multiply each outcome by its probability and then add them all up. That's all we're going to be doing, okay? So let's go back to that pet example. So our educated guess was 2, okay? So I want to find it. So by doing that, you're going to say the random variable times its probability, and then you're going to add it all up. Okay? So I'm going to say 0 times 0.12, and that gives me 0. 1 times 0.20 gives me 0.20. 2 times 0.40 gives me 0.80. 3 times 0.15 gives me 0.45. And 4 times 13, I don't have my calculator, that's going to be 2, I think that's 52, because that's 12, carry it, yeah, 52. We're going to add these all together now, okay? So 5, 6, 7, 10, 19. So 1.97. So I expect a random person to have 1.97 pets. Well, you can't have 0.97 pets. But what does that round up to? That rounds up to that 2 that we guessed, okay? Now, sometimes the probability is so like, bam, here's the highest one, and you can guess it. Now, sometimes you cannot guess it, okay, and the probabilities are a little too close, and you need to do this, all right? Especially if they ask you for the exact expected value, you need to do the formula, okay? All right. So it says the probability distribution function of x equals the number of major defects on a randomly accepted appliance is as follows, okay? Now, it's looking like I'm expecting there to be about 2 defects on a randomly selected appliance. But let's do the expected value real fast. All right, so we're going to multiply, okay? I'm going to say 0 times 0.08 and get 0.08. 1 times 0.15, 0.15. 2 times 0.45, 0.90. Let's see, 3 times 0.27 is 0.81. And then 4 times 0.05 is going to be 0.20. Then we're going to add all these up. Okay, and I'm going to do that. Calculator. And I get it to be 2.14, which is exactly kind of what I guessed it to be. Okay? All right. This one is the number of household members X, living in Cityville homes has the following probability distribution. So this is, I want to know the expected size of a household in Cityville, okay? Let's see. Let's move this table real fast. There we go. All right. So what I'm going to do, let's see. Can I make, I don't like how it's like not fitting very well. There we go. Beautiful, guys. Beautiful. All right. So again, I want to find the expected value. Now, if you look here, I've got a 0.21, a 0.28, and a 0.22. I would logically say 2, but those high probabilities could skew it a little, skew it. Jesus, help me this morning. Skew it a little bit. Okay, so I would definitely do it on this one, okay, because those probabilities are way too close, okay, and even that 0.16 kind of affects it. So we're just going to sit here and we're going to multiply. We're going to multiply our random variable times our probability, and in the end, we're going to add it all up, okay. That's 0.56. 3 times 0.16 is 0.48. That's 0.88. 0.30, 0.24, 0.14. My handwriting getting a little sloppy as I get down the road. Let's see, we're going to say plus 0.14 plus 0.08. Then we're going to add all these up. And I'm going to get 2.89. So see, that kind of rounds up to 3, so I kind of would have been off on that one, okay? But you see how that 0.22 and 0.16 was pulling it a little bit over 2? So the expected size of a household is going to be about 3 people, okay? Now, it is so important for you to find the exact expected value because we're going to add functions to this, okay? So you really need to know how to calculate the raw expected value. Okay, because it's going to help you with the function, okay? All right, so expectations with functions. We can also factor in functions to evaluate along with the expected value because there's some things we want to find out on top of the expected value, okay? So this one right here, there's a huge long formula, but instead of multiplying each outcome, we're going to plug the outcome into the function that we're going to plug the expected value into the function, okay? So what you're going to do is you first find the expected value, you write your function, and then we're going to plug the expected value into the function, okay? So example 4, it says we're going to go back to the defective appliances, okay? So we found this expected value to be, let's see, let's go back up. Where's the appliances? Okay, so on the appliance one, we found the expected value to be 2.14, okay? So we've already found the expected value, so we're going to put E of X to be 2.14. All right, we already done the work. We're good. That's the expected value, okay? Now, it says with no defects. So you remember back in Math 1 how you created a function given a scenario? This is exactly what we're doing right now, okay? So it says with no defects, the cost is $300. So that says with no defects, you're going to pay $300. So am I multiplying that $300 by anything? No. I am flat out saying no matter if you have defects or not, you're paying $300, okay? Now, for every defect, there's 100 times the square root of the number of defects reduction in price. Well, if you're reducing something, am I going to add or am I going to subtract that? I'm going to subtract that. So I'm going to subtract 100 times the square root of the number of defects. We're going to make that X. And that's your function. Now, I want to find the expected price of a randomly selected appliance. So I've already found the expected value of how many defects I could possibly have. Now I want to put a price to that expected value. Well, we just did that with that function, okay? This function right here is going to show you how much you're going to pay for an appliance. But I want to find the average cost that I could pay. Well, this is the average amount of defects I could have. So I'm going to plug that average into this X, and that's going to give me that average price. So I'm going to say Y equals 300 minus 100 times the square root of my expected value. Plug this into the calculator. Oh, let me get my calculator clear. There we go. 300 minus 100, square root of 2.14. So I am expected, now price is 2 decimal places, so I'm going into this store expecting to pay about $153.71. Okay? So that's all you're doing. All right? All right, let's do the next one. So this is given a company that receives a number of orders a week. Okay? So that's my thing. It says for each order, it costs $25 for each item plus the standard shipping fee of $7.50. All right, let's write a function for that. So for each order, it costs $25 for each item. So $25 for each item. So if I tell you you go into a store and it costs $5 for each item you get, how are you going to do that math? You're going to say 5 times whatever item, how many items you get, right? So I'm going to say Y equals 25x, okay? Then I'm going to pay, I just can't talk this morning, guys. It's probably I haven't finished my whole cup of coffee yet. That's why. So it says plus the standard shipping fee. All right. Oh, and here comes the kids. So when you go to mail something, am I going to pay $7.50 for every little item in that box? No, you pay $7.50 for the whole box. So I'm going to add, it's just like when you're checking out online at Target or something like that. They give you a standard shipping fee, right? It's just a flat rate. They don't multiply by anything. They just add it to your order. Okay? Now I want to find the expected price. Well, to find the expected price, I'm going to have to plug in the expected value into that X. Well, let's go back up here and let's find the expected value. Okay, to find the expected value, we're going to multiply all of these across. Okay, so give me, let's see, 41 times 0.03. All right, so we did all the work. I multiplied the X times the P of X, and then we added it all up. So my expected value, so I expect 44.61 items to be in each shipping thing, okay? So we said the function, my function got erased, was 25x plus 750. So I'm going to take my expected value that I just found, and I'm going to plug it in. It was 44.61. So I'm going to plug it in, use my calculator. And so I expect the price for me to ship is going to be $1,122.75. That's a lot. That's a lot, guys. All right. So that is it for expected value. All right, guys.